Today we discuss numerical integration. Here we discuss the approximation of certain integrals by sequences. So the limits of sequences can be computed numerically, which we have already studied. We discussed three different methods: the Riemann sums, the trapezoidal rule, and the Simpson's rule, in which the Riemann sums are familiar to you. You have studied it in the previous semester. So the first one is the Riemann sums. So we define the Riemann sum S as S is equal to B minus A by N into F of x naught plus F of x1 plus etc. plus F of xn minus 1, or S is equal to B minus A by N into F of x1 plus F of x2 plus etc. plus F of xn, to evaluate integral a to b f of x dx, where xi is equal to a plus I into b minus a divided by n. Then this integral a to b f of x dx is approximately equal to s. Now, of course, this approximation becomes better as n tends to infinity. One example, let f of x is equal to cos x. Evaluate integral 0 to pi by 2 cos x by the method of Riemann sums, taking 10 equally spaced points from x naught equal to 0 to x 10 equal to pi by 2. Compare the answer with the actual value. So note that from x naught to x 10 we have 11 points. So we consider the 10 points x naught to x 9. Here x naught, f of x is cos x, x naught equal to say 0, n equal to 10, a equal to 0, b equal to pi by 2. And by definition, xk is equal to a plus k into b minus a divided by n. So therefore, x1 is equal to 0 plus pi by 2 minus 0 divided by 10 into 1, that is pi by 20. And x2 is similarly 2 pi by 20, etc. x9 is 9 pi by 20 and x10 is 10 pi by 20. So by Riemann sums, by the method of Riemann sums, integral 0 to pi by 2 cos x dx is approximately equal to, say it is b minus a by n. So pi by 2 minus 0 divided by 10 into cos 0 plus cos pi by 20 plus cos 2 pi by 20 plus etc. plus cos 9 pi by 20. And by calculation, it is approximately equal to 1.07648. The actual value is sin x between 0 and pi by 2, which is equal to 1. So you can observe that there is an error of 0.07648, or approximately 7.6% error is there by using the Riemann sums to calculate integral 0 to pi by 2 cos x dx for 10 different points. Again, the next one is the trapezoidal rule. To calculate an approximation to integral a to b f of x dx, let xi is equal to a plus b minus a by n into I, as in the previous case, and form the sum s is equal to b minus a by 2n into f of x naught plus 2 into f of x1 plus 2 into f of x2 plus etc. plus 2 into f of xn minus 1 plus f of xn. Then integral a to b f of x dx is approximately equal to s as n tends to infinity. So note that what we do here is we will take the average of the both the Riemann sums, both the values of Riemann sums, when s is equal to this and when s is equal to this particular value, their average is b minus a by n. So the first s into f of x naught plus f of x1 plus etc. plus f of xn minus 1, plus the second s is b minus a by n into f of x1 plus f of x2 plus etc. plus f of xn, the whole divided by 2. So it will be b minus a by n, which is a common value, by 2. So b minus a by 2n into f of x naught is once, and f of x1 is twice, f of x2 is twice, etc. f of xn minus 1 repeated twice, and f of xn is once. So this will be f of b minus a by 2n into f of x naught plus 2 into f of x1 plus etc. plus 2 into f of xn minus 1 plus f of xn. So it is nothing but it's an average of the Riemann sums for these two different values of s. So let us repeat example 1 with trapezoidal rule and compare the values. So repeating the example 1, we can see that the value is approximately equal to 0.9979, which is more accurate than the previous one, and there is an error about say 1 minus 0.9979, that is almost 0.2 percentage error only occurs compared to the 7.6 percentage error while calculating using Riemann sums. Again, another example with n equal to 10, estimate numerically the area of the surface obtained by revolving the graph of y equal to x by 1 plus x square about the x-axis between 0 and 1. So the equation for the area is area equal to 2 pi integral 0 to 1 y into root of 1 plus dy by dx the whole square dx. So calculating dy by dx and integration will become in 2 pi into integral 0 to 1 x by root of 1 plus x by 1 plus x square into root of 1 plus 1 minus x square whole square divided by 1 plus x square whole raised to 4 dx. And by simplification, the integrand is x into root of 1 plus x square the whole raised to 4 plus 1 minus x square whole square the whole divided by 1 plus x square the whole cube. So it is not that easy to evaluate this integral. So what we do is we will make use of the numerical integration. So here we use the trapezoidal rule. Therefore, f of x is this particular integrand, a equal to 0, b equal to 1 and n equal to 10. So let us evaluate, let us find out x0, x1, etc., x10 and f of x0, f of x1, etc., f of x10. Then by trapezoidal rule, the area is approximately equal to 2.3757 square units. The final one is the Simpson's rule. So what we do is to calculate an approximation to integral a to b f of x dx. We assume n is equal to 2m. So we always assume that the number of partition is an even number. And we again xi is equal to a plus I into b minus a by n. And form the sum b minus a by 3n into f of x0 plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 plus 2 times f of x4. That is all odd case. So f of x case. They are multiplied with 4 and even ones are multiplied with 2 except the first and the last, x0 and xn. F of x0 and f of xn are written as it is, but the remaining are either multiplied with 4 or 2 depending on whether this I value is even or odd or even. Then integral a to b f of x dx is approximately equal to s. So let us repeat the first example with Simpson's rule. So we observe that the actual value is 1. We observe that the calculated value is 1.000034, which is more accurate than the first two evaluations. So it is approximately 0.0034 percentage error. Again, another example is you are given some f of x value, xi values. Evaluate integral 0 to 1 f of x dx using Simpson's rule. So just insert the values of these functions in the formula for Simpson's rule. You will get the value as 1.635. Thank you.